Uh, Today we will discuss basics of integration, because the process of integration is very much important, or it is necessary for solving differential equations. Without knowing what is integration, you cannot solve differential equations. So I'll start from very basic, that is, we know the derivative of sin x, that is cos x. When the derivative of sin x is cos x, the antiderivative of cos x is sin x. Instead of saying we call it as integral. So from this equation, we get integral of cos x. We write integral and this dx. Of this cos x, the integral is sin x. Now from every equation corresponding to derivative, you can obtain an equation in integrals. So what is the conclusion? You leave that background. The conclusion is integral of cos x is sin x. Similarly, we have the list integral of sin x is minus cos x, so on, so on. Now, let us discuss very important formulas only. So, I will start with the first basic formula, that is integral of x to the power of n dx, that is equal to x to the power of n plus 1 by n plus 1. Be careful here, the variable is x, n is some power, and d is used, differential is used for the same variable here. If it is y to the power of n and dx integral, then you should not answer, because we are doing integration with respect to x and y is discussed here, and there is nothing given that y is constant, nothing given that y and x are related. What is the relation? So be careful. The main important point is whatever variable appears here, we should do the integration with that same variable. So with that basic point in the mind, the formula, first formula is integral x power n dx is equal to x to the power of n plus 1 by n plus 1. Whatever n is appearing, that n you will write here. But the formula fails in one special case. If n is minus 1, minus 1 plus 1 becomes a 0. 0 in the denominator is a problem. That is infinity. So what we do? What we do is, we say that this formula is applicable only for n not equal to minus 1. Now we will check out this formula, or we will calculate the integrals with the different values of n. One such example. I am writing examples now. One example. You tell some power of n, x, that is x cube dx suppose. The value of this one is x to the power of 4 by 4. How I got this 4? 3 plus 1 by 3 plus 1. So x to the power of 4 by 4. Everywhere we write one constant, but while doing several integrals, you can attach one constant at one time. So I am not writing the arbitrary constant in all formulas. Just to keep in mind that integral value, you can attach one constant also. You can say that it is plus c. Is the point clear? I am avoiding to write the arbitrary constant. Everywhere you can attach that constant. Okay? So this is one example. Example with a different value. Suppose I have 1 square dx. So what should I do first? I should make it look like this one. So what comes? X to the very minus 2 dx. Then it's looking like x to the power of n. So what comes now? X to the power of minus 2 plus 1 divided by minus 2 plus 1, n plus 1, x to the power of n plus 1 by n plus 1. Following? Good. So what it will be now? X to the power of minus 1 divided by minus 1. This minus 1 can be written in the numerator, so it is just minus. X to the power of minus 1 is nothing but 1 by x. As we brought this like this, we are taking it down. So minus 1 is the numerator, x to the power of minus 1 is 1 by x. So what is the integral of 1 by x square? Minus 1 by x at the last. Okay. Now third case, just with the fractional power, for example, root x dx. What it is now? Integral, okay, very good, x to the power of 1 by 2 dx. Now that is good, x to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1. 1 by 2 plus 1 is 3 by 2. So that becomes x to the power of 3 by 2 by 3 by 2. This 3 by 2 comes in the numerator, becomes 2 by 3. So it is 2 by 3 and x to the power of 3 by 2. X to the power of 3 by 2 is nothing but x root x, because x power 1, x power half, and 1 and half, that will be nothing but 3 by 2. So are these three examples clear to you? No need to repeat again. These are different examples for the cases of different n values. So what is the formula you have learnt now? Integral x power n dx is equal to x to the power of n plus 1 by n plus 1. But this is applicable only when n is not equal to minus 1. Here the integral is written for n not equal to minus 1. Let us then now see what is the special case when n is equal to minus 1. When n is minus 1, what this will look like? X to the power of minus 1 dx. That is nothing but integral 1 by x dx. This comes down. Integral 1 by x dx. In the beginning of this session, I said that when the derivative of f of x is g of x, some function, then integral of g of x, this integral is nothing but equal to f of x. Is the point clear? When the derivative of f of x is g of x, then the integral of g of x is f of x. You know very well the derivative of log x is 1 by x, right? The derivative of log x is 1 by x. So what is the integral of 1 by x? That is equal to log x. So integral 1 by x dx, that is equal to log x. Nothing written, but it is to be treated here. Actually this integral is log x under base e. So these two makes up one situation. If n is not minus 1, that one, okay. If n is equal to minus 1, this case. So note it down. As I said in the beginning, it's discussing only basics of integration. You have a long list of integrals. It is better that you memorize that one, but frequently getting used, only I am writing here. So what is the first one? Integral x to the power of n dx is x to the power of n plus 1 by n plus 1, n not equal to minus 1. It's a special case. 1 by x dx is equal to log x base e. Integral cos x dx is, I said in the beginning, that is sin x. Integral sin x dx is minus cos x. The list continues. You can get this list of integrals, standard functions, from any textbook or from any PDF file which is written for this one. You can get it. So what I suggest you go through this list. Now let us see how to calculate the integrals based upon this some frequently used functions. And trigonometric functions are there, inverse trigonometric functions are there, hyperbolic functions are there, but I am discussing most frequently used one, that is integral e to the power of x dx is equal to e to the power of x. Suppose if 2x comes here and dx is available, what to do? Then we have a very special method called method of substitution. Using that method of substitution, we can talk about cos 2x, cos 3x. Okay, let us do that work now. So this at least minimum 5 you copy this one. Now what will be integral 1 dx? Then this comes again from the first beginning formula, that is integral x to the power of 0 dx. That's equal to x to the power of 0 plus 1 by 0 plus 1. That becomes x, this becomes 1, and I need not write that one, it becomes x. So it is to be memorized that integral 1 dx is x. What is the short way of looking at that? This always, this integral sign and d will get cancelled, the remaining quantity, that is x, appears. So what will be integral dy? 1 is not there here, we can assume that 1 is there here, and we can write q. So finally what will be this one? Integral dy is y, integral dt is t. Is this clear? Okay. Now the very special thing starts now. In the background we just discussed some of the standard functions integrals of some standard functions. There are two things keep in mind. One is the list of formulas, and the other thing is rules of integration. Using the rules and the list, you can derive the integrals for so many functions. What is my conclusion? You need to remember the rules and also you need to remember the list. Once you remember these two, then you can find the integrals of so many functions. Any function actually. Rules you should know the list. The first rule comes here, that is sum rule. Suppose I have one function f of x and another function g of x. If a constant a is multiplied here and a constant b is multiplied here and added or subtracted this way, then this becomes a new function. The integral of this new function with respect to x, because x is the variable used here, then that is nothing but just take the constant a outside, integral for this function f of x, and then constant b outside, integral for g of x. Now using this rule, it is also called linearity property. Using this rule, simply we have the function, suppose 2x square, or I'll make it as 2x cube plus 4 sin x. This function we want the integral. What to do now? Take the constant 2 outside, write integral x cube dx plus take the constant outside 4. If minus appears, minus will be there. So here if plus appears, plus will be there. If minus appears, minus will be there in that rule, right? I'm sorry, I missed that minus. So is the point clear? So if a plus is there, plus will appear, minus is there, minus will appear. That constant is out. Now I should write integral sin x dx. That's equal to 2 into, you know this from the list of formulas, x to the power of 4 by 4 plus 4 into, what is the integral of sin x? Minus cos x, okay, minus cos x. So this complete, you can cancel 2 and you can write it next step as x to the power of 4 by 2, x to the power of 4 by 2 minus coming out 4 cos x. What is this one now? It is the integral for 2x cube plus 4 sin x. Okay, if you have any doubt you ask. No doubt, then you copy this. Now very important rule, that is integration by substitution. Integration by substitution. Suppose we have integral, I'll write the question full. Evaluate means find the value of, evaluate 3 cos 4x dx, integral of 3 cos 4x dx. So solution, I'll write it, integral 3 cos 4x dx, that is equal to 3 coming out. As per the previous rule, there is no second term. If there are 3 or 4 terms, you will separate the integral for 3 or 4 terms with plus and minus. If it is a product, we have to go for integration by parts, that we will see after this integration by substitution. If there is a plus in between two functions, we will separate the integral. If there is minus, also we can separate. But if it is a product of two functions, f of x and g of x, f of x into g of x, then some rule is not applicable. We will go for integration by parts. Now 3 coming out. So integral, I am writing detailed steps right now, but in next problem we can directly take the jump. Now this is x here. I said you that same variable x appears here, it's okay, but it is not the variable x, it is 4x. So let us take 4x as t. What I am doing now? I am taking 4x as t. I will write in brackets, let 4x is equal to t. Now I am applying d for this complete. Then 4 into dx. This 4 is outside constant. D is applied to this x. What comes now? Dx. D applied to this one, it will become dt. So 4x dx is how much? Dt. What is dx from this one? Dx, just a simple dx, that is dt by 4. 4x is t and dx is dt by 4. These two things let us substitute it here. Integral 3 into integral cos, it will become t, and in the place of dx we will substitute dt by 4. That is equal to, this 4 is a constant again, it will come outside the integral, it will become 3 by 4, integral cos t dt. Earlier I said in the list you are having integral cos x dx, that is equal to sin x. I said earlier that if it is x, it should be x only. If it is y here, you cannot say what is the value of this one until and unless you treat y as constant or you know the relation between y and x. So be careful, this variable should match with this variable. If it is t here and it is t here, then it will be sin t. So what will be this one now? Integral cos t dt is sin t. So this will become equal to 3 by 4 sin t. But the answer should be in x, not in t. So substitute back the t value. So it's how much now? That's equal to 3 by 4 sin 4x. Now let me say a formula comes out of this one, that is, this 3 is of course a constant that has come out, that 3. What that cos 4x integral has become? This 3 is this 3 over. Final answer you compare with this one. So having cos 4x, that 4 which is the derivative of this 4x has come in the denominator. So what rule comes out now? Integral cos ax dx. Here it is x, here it is ax. So what it will be now? No need to write substitutions, all these things. This I have done only for one problem. What is the direct step for this one? It will be sin ax divided by a. Cos 4x has become sin 4x, and in the denominator we had this 4. That 4 is the derivative of this 4x, that a. So what it will be in the case of sin ax? You can make a conclusion. I hope you will be able to tell. What it will be now for sin ax? Minus, very good, cos ax by this a. Okay. Now we discussed earlier, integral of e to the power of x dx, that is equal to e to the power of x. If t comes in the place of x, we have e power t. There is no issue with this one. So whatever name of the variable is there, that same variable name will appear on the right hand side. Let us use the concept of this formula and the substitution to evaluate this integral. Evaluate integral e to the power of x square into x into dx, or x written here anyway, x dx. Solution. Let I is equal to, I am giving the name as I, x into e to the power of x square into dx. Is the point clear? So we need some substitution now. What is that substitution? This x square let us take as t. Let x square is t. Now you apply d for this one. D implies d of x square is d of t. D of any function is derivative into d of that variable. D of x square is how much? Derivative of x square into d of that variable. D of that variable is dx. What is d of t? That is simple, dt. Or d of t is derivative of t, that is 1, into d applied to this t, that is dt. So it is 1 into derivative of t with respect to t is 1, d applied to t, that is dt. But no need to write that 1 dt, we can simply say it is dt. Okay, good. What is x dx? This part is available with us, x dx. So this x dx will become dt by 2. What we are doing now? We are converting this integral in terms of x to t, new variable. So therefore I is equal to, with this adjustment, what is that I going to become? Integral e to the power of t, okay, and x dx is replaced as dt by 2. Now this 2 is a constant coming out in the denominator, so it is 1 by 2 integral of e to the power of t. It is exactly simple, e to the power of t. But what is t here? Substitute back that t as x square. So you will be getting this equal to e to the power of x square, this whole by 2. Everything clear? Okay, please copy. Suppose we have 2x as one function, e to the power of 3x is another function. First of all, let me answer, what is e to the power of ax dx? That is, by substitution, take ax equal to t, ax equal to t, a into dx is equal to dt. So dx is equal to dt by a. This dx I will write as dt by a, and this I will write as t here. So this a comes out 1 by a, e to the power of t integral is e to the power of t, but t is nothing but ax. Therefore this becomes e to the power of ax by a. So from all these steps, what is the final conclusion? That integral e to the power of ax dx is e to the power of ax divided by a. You need to just remember that one. Okay, clear about this one? Back to the point. If I have plus here and I want the integral of this one, then what is the rule I am using? Just a separation. Because there is a plus or minus, not only one, even if it is 3 functions, for example, minus sin x dx. So any number of functions you are having with plus or minus, you can separate it. That sum rule was written only for 2 functions but extended to any number of functions. Come on, you tell now, what is this result? 2 into integral x. I am avoiding some steps now. I am not writing like earlier problems detail. So what is the integral of x? Directly write that integral. X square by 2 plus. What is the integral for e to the power of 3x? That integral symbol I am removing and I am writing the integral values. You might have noted. So what is the integral e to the power of ax dx? That is e to the power of ax by a. So what is for e to the power of 3x? E to the power of 3x by 3. That 3 will come in the denominator. Next, minus as it is. Integral of sin x is minus cos x. So shall I make it as plus here? And I will write it as cos x. Okay. So if we are working with some solution, then we need not write all detailed steps. If this is the integral, you can directly take these steps. Okay. So this becomes equal to x square plus e to the power of 3x by 3 plus cos x. No need of writing brackets, all these things. I have removed the brackets. Okay. Just now we discussed integral 2x into 2x plus e to the power of 3x. Let us say only these two functions are there. Then we will separate it. But the question comes like this, suppose e to the power of 3x. What is happening here? We are having the product of two functions. Okay. It is not sum. In the case of product, we need to use the product rule or integration by parts. Integration by parts. What is that rule we will see first, then we will use that rule to calculate this integral or evaluate this integral. This integration by parts you need to memorize. How to memorize? I will give you some tip. First of all, let me write that formula. Integral, you are having two functions, f of x and g of x dx. Integral for this product is, first this function you take as it is. If there are two functions, which to be treated first function, which to be treated second function, there is a rule called ILATE rule. You know that ILATE rule. I will tell about that ILATE. Okay, which to be taken first function, which to be taken second function. With an example I will demonstrate that one. First of all, I am writing that formula. Integral first function as it is. Then you write integral for the second function. Got this point? Means this complete is finally the integral of g, that is to be multiplied with f, minus integral. Be careful, here integral is coming inside one more integral. So it is outer integral. Derivative of this first function to be taken. Here function is taken, here derivative is taken. And then this complete bracket you copy as it is. That is integral g of x dx. Again for this complete you will do integration. This particular bracket is integral of g. This integral of g, one time it is multiplied with, now I am giving the tip to remember, this is repeated two times. One time we are just multiplying with f, one time we are multiplying with f dash x, and then this product again we are doing the integration. So to do this integration, first of all you have to simplify this one. So once it is simplified, then for this product again we will do the integration. Okay, you write this formula. Naitik. Okay, that ILATE rule is the short form. Okay, full form is like this. I stands for inverse trigonometric function, L stands for logarithmic function, A for algebraic, T for trigonometric, and E for exponential function. This is the priority. First function should be selected as inverse. If it's not available, you have to go for this one. Let me say, for example, I have integral sin 2x into x square dx. If the problem is given in this way, sin 2x into x square. But if you see these two functions, this is algebraic function, this is trigonometric function. So in this order, as per this one, what should be the order? A should come before t. So you have to write this a first, this t next. So this integral you should calculate by giving the position as x square comes first. Why x square is coming first? In the order of preference, a comes first, t comes next. So algebraic function should come first. What is algebraic function? Powers of x simply. X square, x cube, x power 4, or sum of algebraic functions x square and x cube, or 4x square plus x cube. Only powers of x should be there available, and added or subtracted, that sum of the powers of x, that is algebraic function. In short, actually it is polynomial function. Polynomial function. Back to the point, x square takes the first place, so this becomes the first function. The second function becomes sine 2x. This is second function. So this first function to be treated as f of x, second function to be treated as g of x. Then you know what is integral. I am repeating again, integral f of x into g of x dx. Can you repeat along with me? F of x into integral g of x dx minus integral f dash of x into integral g of x dx, this complete with dx. Okay. So now let us proceed to calculate this one. For the sake of convenience, I am just taking x in this case. So even x is algebraic. So if the question comes evaluate integral, it is given like sine 2x into x dx, but in the solution we will rewrite it as integral sine 2x into x dx is nothing but equal to integral x into, as per this it is algebraic, that should come first, trigonometric should come next. So x into sine 2x dx. Come on, tell me what is f of x? That is x. What is g of x? That is sine 2x. Now what should I write here? F of x. Very good. F of x, that is x. Integral of g of x, that is sine 2x dx minus integral f dash x. This f dash x is nothing but derivative of this x, that is 1 into this integral of sine 2x dx, this complete multiplied with this one, this whole dx. I hope you are clear. Now what is the value of integral sine 2x? Earlier we have seen shortcut formula, integral sine ax is minus cos ax by a. So it will become minus cos 2x, because it's 2x here, by 2. Whatever number is there, that number will appear here. So x is there as it is, minus 1 is disappearing. What is this integral? This integral is nothing but the same exactly. So I will just copy this one, integral. This bracket will come, of course, like this as it is. So minus cos 2x by 2 dx is as it is. So minus I will take it outside. I will just simply write minus x by 2 into cos 2x over. This becomes plus and 2 comes out. So it is plus 1 by 2. What is remaining now? Plus 1 by 2, that constant is outside. So integral cos 2x dx. How much will be integral cos 2x dx? Directly it is sine 2x. Cos integral is sine, positive sine. Sine integral is minus cos. So cos integral is how much? Sine. But because it is 2, that 2 will appear. And next step, it is so simple, minus x by 2 cos 2x. Just you are writing that constant 1 by 4. into sine 2x. So this is the integral for this one. Even though it is given in this way, as per ILATE rule, we have written x first position and then sine 2x in second position. If inverse trigonometric is appearing and exponential is appearing, then first inverse trigonometric, then this one. Several combinations are there. Several combinations. Among that combinations, if two functions, you have to rearrange as per this rule. Okay? Listen, whenever we want to handle the problem of integral, in the background you should have two things. I said, what are the two things? Number one, you should memorize the list of formulas. So first comes list. Tell some of them. Integral e to the power of ax dx is e to the power of ax by a. Actually, I have written basic formula e power x dx is e power x, and by substitution we arrived this one. So the list is now like this: integral cos ax by integral cos ax, that is equal to sin ax by a. This is not fundamental formula, it was brought from fundamental formula by the method of substitution. So you have the list. Tell some more. Integral 1 by x dx is log x. So many will come in the list. You have to memorize this list from some textbook, you take it and memorize the list. This is list concept. Okay. Next concept is rules. In the rules you have some rule of taking the substitution, and next integration by parts. So you have the rules. Integration by parts is one rule, some rule, all these things. Next comes just use of list and rules to do the problem. Let us handle one problem just. If the question comes integral x e to the power of x square plus x square sin x, this complete with dx. Now what to do? This integral is at first step, using the sum rule you can separate it. You can write as two integrals. What are the two integrals? Integral x into e to the power of x square dx plus integral x square into sin x dx. Then this to be calculated separately. Instead of running this step, you can then do like this. Now integral x into e to the power of x square dx you give as equation number 1. Means this integral is the sum of two integrals. That is equation number 1. Let us calculate only this part now. Then it is equal to integral e to the power of t, x square is t. Same problem we have done some time back. By taking x square is equal to t, 2x dx will become dt. So x dx is dt by 2. So this x dx will become dt by 2. That's equal to 1 by 2 integral e power t dt. That's equal to e to the power of t by 2. That is e to the power of x square by 2. We got this. Similarly, you have to calculate this integral. What is the rule? Product rule. Product rule. This was by substitution, so simple. You have first function as x square, second function as sin x. Then product rule you have to apply, you will get the result. After getting both the integrals, you substitute back here, you will get the various integral. Okay. So you have to start again with now integral x square into sin x dx is equal to x square into, try to tell the direct step now. That integral symbol I am not writing. First function into integral of second function. What is the integral of second function? Minus cos x minus integral. Now the derivative will come. Then this same part will appear because integral g of x dx will come one time with f of x, one time with f dash x. One time with f of x, one time with f dash x, f dash x. Here integration is done, here directly multiplication. So this minus cos x to be copied as it is. Then that is equal to minus x square cos x. This 2 constant comes out, minus of this minus, that is plus 2 into integral x into cos x dx. Again you see here it is a product of two functions. So you have to again further continue by taking f of x as x and g of x as cos x. You can do that one. This work we have already done with sin x, I think previously, x sin x we have done. Okay. Here you try to understand this to be solved again by integration by parts. It will be lengthy. Okay, you have done that work. I am not doing, because there is a shortcut available. I will tell you that shortcut. So even if you calculate that one, this complete becomes the value of integral x square into sin x. Just imagine how it will be integral x cube sin x dx. Can you imagine what will be this one? It will be very lengthy, because you have to take it as equal to, come on tell, x cube into minus cos x, very good, minus integral derivative of x cube 3x square, very nice, that is over, minus cos x as it is, minus cos x dx. Now minus x cube cos x, not a issue, that is good. This minus into minus becomes plus. 3 is outside. Integrate with x square cos x dx. Now this integral x square cos x dx is similar to integral x square sin x dx. Then again there will be one more integral. So you can imagine how it will be difficult when the power of x increases. So let us not use integration by parts for higher powers of x. If it is just one power of x, it's okay. For higher powers of x, there is a very simple shortcut formula, that is a rule. That rule is Leibniz rule. Leibniz rule for integration. I am not writing, because we are dealing with only integration. So it's so simple. Okay, you see here integral u and v. There are two functions. We are calculating the integral now with respect to x. Then what you do is, carefully see the notation how I am writing. First take the function as it is. As in integration by parts, we are taking first function as it is. Which is first function, which is second function? Same ILATE rule. First function, second function to be decided as per ILATE rule. That is done. Once it is done, this is u. Now take the integral of v dx. Okay, instead of writing integral v dx, I will simply say here v1. What I meant to say here? First integral of v, that is integral of v, simply. You write alternate plus minus. Now take the derivative of this one, that is u dash. Okay, first u as it is, integral of second function, minus derivative of first function into integral of this one. It is already integral. So what you do? You write v2. What is v2 now? v2 is integral of v1. v2 is integral of v1. Then plus. I will remove this. Okay. Can you guess what will be the next term? Alternate plus minus. Derivative of the first one, integral of the second one. So this u dash you have to write now. U double dash. What is u double dash? Derivative of u dash. Derivative of u dash. And v3. v3 is integral of v2. Every term having two things, right? First one is the derivative of the first one. Second one is the integral of the second one. Is this point clear? Now can you make a guess what will be the next term? First will be derivative of the first one, that is u triple dash. Second one will be integral of this second one. So what is the integral of this V3? I will write V4. That is integral of this V3. Next, plus u fourth derivative into V5 minus. So this gets continued. This is Leibniz rule for integration. You copy this rule. Copy this. Just now I said you how to remember that Leibniz rule. Now you tell me what is integral u into v dx. Come on. U. First is u. Okay, good. V1. Next, minus. Alternate plus minus. Come on, fast. U dash V2 plus u double dash V3 minus triple dash V4 plus so on. Leave it. Now let us find integral x cube sin x dx. So nice, we will proceed by using this one. What is u? X cube. What is v? Sin x. Now in the bracket you write the first function. What is the first function? X cube. Now in the bracket you write the integral for this function. What is the integral for the second function? Sin x is second function. What is the integral? Minus cos x. Okay, good. Minus cos x. Once again I say, you write just these two and forget about this part now. You can proceed just by looking these two terms and you can write it. Minus, two things will come now. In the first bracket, derivative of the first bracket, previous term, okay. In the second bracket, integral of the second bracket. In the first one, derivative will come. In the second one, integral. From where? From previous term. So what should I write now? Derivative of this one, that is 3x square. Here, integral for this one, minus is there and cos x integral is sin x. So minus is as it is, integral of cos x is sin x. This is over. We are up to here. Next, you need not remember this now. This rule is written to make you understand. Once you understood, no need to see that one. Directly you can proceed. Plus, again two brackets, minus, again two brackets. I hope you are following. So this step. Now you no need to see this one now. Just to see this one. What you need to do now? Derivative of the first bracket. Very good. 6x. Integral of the second bracket. Minus. Integral of sin x is minus cos x. So minus into minus becomes plus. So finally it becomes cos x. Now 6x, derivative is 6. Integral for cos x, that is sin x. Next, plus derivative of 6 is 0. This derivative we don't require because this has become 0. So from here onwards all terms will be 0. So it will end up. Now we can simplify this one. It's how much? Minus x cube. Come on. Cos x plus 3x square sin x plus 6x cos x minus 6 sin x. How fast we got it? Clear? So it's so simple. You can do it very easily. Suppose you have x cube into e to the power of 2x dx. What we do? Come on, tell. First function x cube. Second function integral of this. E to the power of 2x by 2. Next, minus. Once you have written these two, first function as it is, second function integral. No need to see this part now. Just continue. 3x square. Integral for this bracket value, complete bracket value, you have to find the integral. So e to the power of 2x by 2 with one more 2 here. So it will become very good, e to the power of 2x by 4 plus 6x into integral for this one, e to the power of 2x by 2 along with this 4, it will become e to the power of 2x by 8 minus 6, okay, good, into e to the power of 2x by 16. Just simplifications, I am not writing, you can get it. So, okay, acha, really tell, got it? So easily you got it. If you use product rule here, integration by parts, it will be so lengthy. It is Leibniz rule which will help us to calculate the integral very easily. Now to find the integral of any function, what you need to remember? Number 1, list. Number 2, rules. In rules, substitution may come, or depending upon the situation, integration by parts may come. Shortcut you can use Leibniz rule, and at the same time you need to use the background knowledge of intermediate. I mean to say that trigonometric identities you can use transformations, all these things. For a simple problem now, I am not talking about trigonometric functions, just a simple, what is integral 1 by 2x plus 3 dx? We discussed integral 1 by x dx, but we didn't discuss this one. So how this can be settled now? Take 2x plus 3 is equal to t, it looks like 1 by t, it looks like 1 by x, okay, 1 by variable. So let 2x plus 3 is equal to t. Now you multiply, you take d of this one, d of 2x plus 3 is d of t. D of 2x plus 3, I said you d of some function means write the derivative first, derivative of 2x plus 3 is 2, then d applied to that variable name, that is x, and it is equal to dx. So what is dt? So what is dx now? dt by 2. So this becomes how much? Integral 1 by t, dx is dt by 2. This 2 coming out. Integral 1 by t dt is log t, very good, log t, and next step you can make it as 1 by 2 log of 2x plus 3. What is the rule from this one? If it is ax plus b, 1 by ax plus b dx, what will come now? Log will come with, I will remove this part, okay. Come on. The derivative a will come down. So 1 by a log of ax plus b. Okay, you note it down. Suppose if the question comes, evaluate integral 2x plus 3 divided by x plus 1 into x plus 5. Then if you see in the list, you don't get this function. If you want to use the rules, some rule is not applicable. If you want to use integration by parts, that is not applicable here, or else it will become very difficult. Leibniz rule also not working here. It is not so simple to continue. Sometimes what happens, the derivatives will go on continuing. So Leibniz rule, that terms will be continuing. At that time it is not applicable. Come on. What should we do for this one? If suppose just x plus 1 is there, some number here, for example, some k by x plus 1, integral is so simple, k is coming out, log of x plus 1 divided by 1, derivative of this one. So it is no need to write, okay, k into log of x plus 1. And one more part is there, that is, even if it is 3x plus 1, what will come? 3x plus 1, and 3 will come in the denominator, 3x plus 1. If it is suppose 7x plus 4, then if there is some constant k divided by 7x plus 4, integral, then k comes out log of 7x plus 4 1 by 7. If separate terms are there like this, then we can calculate the integral so nicely. But here it is in the form of a fraction where numerator is one function of x, it is not a constant, and denominator is a product of two functions. So we use partial fractions. Let 2x plus 3 divided by 3x plus 1 into 7x plus 4 is equal to some constant a by 3x plus 1. Now there are rules of partial fractions how to split. You just revise that partial fractions plus b by 7x plus 4. What is written here? There are constants a and b. If you continue this, you will get some value of a and you will get some value of b. Let it be some as it is, a and b. What will be the integral for this one then? Integral for this, come on, is equal to integral for this one, this complete. This is written as the sum of two functions. So integral is the sum of means two integrals will appear here. So one will be integral a by 3x plus 1 dx. Whatever numbers are coming there, that numbers will be written here. So what will be the second one? Integral b by 7x plus 4. A comes out. To save time, I am not calculating that a and b values. So a is coming out to log of, very good, 3x plus 1, 1 by 3 plus b into 1 by 7 log of 7x plus 4. Okay. I hope you got a basic idea about integration. First we discussed the list, then we move towards rules. Among the rules we discussed sum rule, rule of substitution and integration by parts, and there is a shortcut for integration by parts, that is Leibniz rule. Then if any problem appears, you split it first of all, then depending upon the parts you apply proper procedure. By doing this way you will be able to find the integrals of many functions which are not in the list, and you can include that in the list. Okay, so I hope you got at least a brief idea about it. You can then practice other methods. Okay, right, thank you.